Great, thanks very much. I'm going to turn my camera off here just so as not to be a distraction, but I'll come back at the end. And if we have any questions, please do put those in the Q&A box and we'll try to get to them as we have time. So welcome everybody. Thank you for joining us today. Let me start by giving you just a little bit of my background so you can see where I'm coming from. I first learned to program in Fortran in college, like so many of us did back then in 1970. That's why the subtitle of my book, Software Development Pearls, is Lessons from 50 Years of Software Experience. Since then, I've had a lot of experience with software development in many forms. In fact, 1/3 of my PhD thesis in organic chemistry was code. I moved from chemistry into full-time software development nearly 40 years ago. Since then, I've also worked as a software manager and a software quality and process improvement leader. In 1997, I started my software consulting and training company, Process Impact, through which I've provided services and products to about 150 companies and government agencies of all types. So one of the interesting things about being a consultant is that you get a chance to see what a lot of people are doing. When I started out in consulting, one of my colleagues at Kodak, where I had worked for many years, said, well, if you're not working on projects all the time, how are you going to keep up with what's going on? And that seems like a reasonable question, but I realized quickly that by working with so many people in so many different companies doing lots of different things, I was able to get exposed to a very wide variety of what people were doing. So through both my personal experience and by observing and hearing from my many consulting clients and students in hundreds of classes that I've taught, I accumulated many lessons and insights about a lot of aspects of software development. This book, Software Development Pearls, presents 60 of those lessons. You know, experience is a great teacher, but it's also an expensive and painful way to learn. You don't have time to make every mistake that every software developer before you has already made. You can avoid a lot of the pain by learning from those who have gone before. And my goal with this book is to help you improve your software effectiveness quickly by reducing the learning curves. Today, I'm going to tell you about the structure and contents of the book. 59 of the lessons are grouped into 6 critical areas of software development. I don't cover some other obviously important areas, such as coding, testing, and configuration management. There are plenty of other good books on those topics. This book contains 16 lessons about requirements, 6 about design, 12 on project management, 8 lessons about culture and teamwork, 8 more about software quality, and 9 lessons on software process improvement. I'm not going to try to cover all of the lessons in this presentation. We'll get through about half. I'll show you several lessons in each of these 6 areas, and I'll also drill down into one lesson in each category in more detail. Finally, lesson 60 is about what to do next with all of this knowledge. The book therefore closes with a short chapter on how to begin your journey toward more effective software development by applying selected guidance from the book to the project challenges that we all face every day. Each of the 6 subdomain topic chapters in the book is structured in the same way. First, I provide a brief introductory tutorial on the topic to give you some background for understanding the lessons. And you'll know a lot of this kind of stuff, but it gives us a common foundation for moving ahead. Then comes a series of first steps to get you started thinking about issues that you and your team face in that subdomain. More about this in just a moment. After that comes a series of essays, one on each of the lessons in that topic. The lessons include many true experience examples that illustrate the lesson, along with key points and descriptions of numerous practices that you can apply on your projects to put the lesson into action. This is not theoretical stuff. This is practical stuff based on what I've learned that works and doesn't work, and what we can do to apply that going forward. Each chapter then concludes with some next steps to get you started. So the first steps in each chapter invite you to retrospect a little bit, reflect on your current situation, maybe list the current practices in that topic area that you're good at in your teams. Also, though, we have to be honest about identifying problems that we encounter in each of these areas, the impacts that those problems have on our project success, and some possible root causes. This kind of little retrospective analysis helps us select new things to do that are going to address the real issues that prevent us from being as effective as we'd like to be. The next steps at the end of each chapter will help you think through how to improve your current practices to get better results. I'll suggest that you identify relevant lessons from the chapter and, of course, your own lessons. I mean, you're all experienced people. You've got your own pearls of wisdom that you've accumulated through your experience and through looking over the shoulders of people on your teams. So let's try to collect that information and see what we can share with our colleagues. You might want to identify specific practices that I recommend or that you know of from other places that could address the problems that you're currently experiencing. I find it helpful to also think about what barriers I might encounter as I set about trying to implement each new practice I want to try. And finally, I'll suggest that you think through some work aids that you might be able to put into place in your organization, things like templates for key project deliverables, procedures, checklists, guidance documents, anything that can help your teams be more effective consistently from project to project. So let's start by taking a look at some lessons in the category of requirements. I've been interested in improving how projects handle their requirements for many years, and I've written several books on this topic. So not surprisingly, this is the area that I have the most lessons in. I have 16 lessons on requirements in software development pearls. And I think this is appropriate, really, because requirements are the foundation that are for all of the project work that follows. So here are 4 of those lessons that I always try to keep in mind. The first lesson says, if you don't get the requirements right, it doesn't matter how well you execute the rest of the project. You're probably going to fail. Now, I don't mean that you need to get all of the requirements right at the very beginning before you start writing code. We all know that that's not very realistic and probably doesn't work well in most cases. Ultimately, though, a successful project requires that you understand the customer's problems and also understand the capabilities and characteristics that a suitable solution must have. Somebody asked me once, well, what's the most important lesson you've learned from your experience? And I think it's this one. Lesson number 4 says, a usage-centric approach to requirements will meet customer needs in almost every case better than a feature-centric approach. I found that it works much better to focus requirements discussions not on the product and its features, but rather on the users and what they need to do with the product. From that usage-centric understanding, we can then deduce, and by we, I mean typically a business analyst or someone who's wearing a business analyst hat at that moment, we can deduce the necessary product functionality that we have to implement to make sure that people can, in fact, do the things they need to do. If you take a feature-centric approach, and that's a very common approach, people say, well, what do you want to have in the software? Well, let's not talk about the software, let's talk about the users. But a feature-centric approach often can yield just a pile of functionality fragments, sometimes written in the form of story cards, that might not let the users get the job done. Another thing that can happen, I don't know if this has ever happened to you, but it certainly has to me. Some of your users or customers tell you they need certain capabilities, so you build them in, and then no one ever uses them. It's very frustrating when that happens because you put just as much work into building each of those features correctly as you did the features that people do use. But if you take a usage-centric approach, that often helps you avoid this problem of implementing functionality that is rarely or never used. People sometimes talk about agile requirements as though they are somehow different from requirements on other projects, but I don't think they are. I think they're the same kind of information. Further, I think developers need the same information to write the necessary code correctly, regardless of the development model being used or how they choose to represent the knowledge. Whether you write functional requirements or acceptance tests or something else, you still need the same knowledge to write the code. So I don't think there is such a thing as agile requirements. There are requirements for agile projects, but I don't like the phrase agile requirements. Some people don't want to take the time to write down information. As I say in lesson 7, I've learned that the cost of recording knowledge is small compared to the cost of acquiring that knowledge. Writing requirements isn't the hard part. The hard part is figuring out what the requirements are. The same is true for other things like project plans. Identifying all the many tasks, dependencies, risks, and so on, that's the hard part. Writing that information down is mainly transcription. And maybe you've been in this situation where you had to figure out what a system does through reverse engineering of the code or of its observed behaviors so that you can modify it. Well, if you ever have to do that, I suggest you write down what you learned so that you or someone else doesn't have to repeat that reverse engineering in the future, so you can make the next change in that part of the system. So I don't have a lot of patience with people who say, well, we don't have time to write this down. We've got code to do. Well, remember this, it costs you more to discover that information than to record it. And also remember, people's memories are incomplete, fragmented, inaccurate, and not very persistent. So I'm not that opposed to writing down what we learn. So those are 4 lessons about requirements that I think are important. Let's take a more detailed look at one more example here. Lesson 12 says that requirements elicitation must bring the customer's voice close to the developer's ear. Unless you're building software for yourself, you'll always have a gulf between customers with needs and developers who build solutions. Each project team needs to establish effective communication pathways between these two communities. Your options depend on how many participants are involved, who and where they are, how well the communities understand each other and their vocabularies, and the software team's skill set and knowledge. Well, here are 5 common communication pathways that projects can use to bring the VOC, the voice of the customer, close to the EOD, the ear of the developer. Once upon a time, I was the only developer working on a project with a single customer, actually several projects, building for them in the Kodak research labs with another scientist. We could talk directly. We sat a few feet apart. We could do a lot just verbally because I could have him come look over my shoulder or look at a screen and give me some feedback right away. That's the ideal solution, but it leads to chaos on a sizable project if a lot of customers are trying to talk to all the developers. In most cases, you need some intermediaries who can broker and facilitate these conversations. But when possible, the direct connection can be helpful. One model that my teams found to work well was to identify distinct classes of users and then to identify specific individuals that we called product champions to serve as representatives for each of those user classes. These product champions would work with the business analysts to develop requirements, and they'd also help with things like making decisions on change requests. And some of our product champions were just terrific, real partners in the development process. They would help us with devising tests and carrying out those tests and helping with writing documentation from the user's point of view and all sorts of things. So this was my personal experience. We started clear back in 1985 in my group at Kodak with this product champion model, and we made sure we had product champions for all of our projects. So interesting thing happened once. I taught a public class on requirements some years ago, and there were some people there from one company. Now, I guess they got excited about this idea because a year later, I taught the same class, and another employee from that same company attended that second presentation. He said that after the first class, they set up product champions for all of their projects, and they really felt that it increased their productivity and the quality of the solutions that they were building. So it's always nice to get that kind of feedback from people that your ideas, your experiences, your recommendations are actually useful to them. Commercial software development companies often have marketing people who are working with product managers to define the market requirements and the solution's characteristics, another common kind of model. Most agile projects have a product owner who establishes the product's vision and goal. The PO creates and communicates the contents of the product backlog. So the PO in that case serves pretty much as both the customer rep and the BA. But some agile teams do include also a business analyst who works with the product owner to facilitate this critical communication between customers and developers. Any of these communication models and others can work. When you're planning a project, take some time to determine the best mechanisms for having suitable representatives communicate requirements information efficiently and accurately to the development team. One of these models might work for you, or you might need to do something a little bit different. So let's move on to design. If the domain of requirements is about defining problems and the characteristics that solutions must have, design is about crafting those solutions. Software design encompasses four major aspects: architectural, detailed, database, and user experience design. All of these design aspects are subject to numerous constraints that restrict the options available to the developers. So a good design must efficiently accommodate enhancement and modification, both during the development process and following release, as well as guiding the initial development work that's done. So here are four of my lessons about software design. I've found that I can't get the design right, or certainly not perfect, on the first try. So I have to plan to iterate as I explore different design alternatives. And incidentally, the same is true about requirements. Prototypes are one effective iteration technique, but I've also learned that it's cheaper to iterate at a higher level of abstraction than on working code. And some, but certainly not all, prototypes do involve building working code. Let me show you what I mean by this. This diagram shows that if we're iterating at a higher abstraction level, such as product concepts at the lower right here, or on requirements, or on design models, that takes less effort and it costs less than if you're repeatedly modifying project artifacts created at a lower level of abstraction, such as the designs themselves or the code. So a sweet spot for iteration is right here around in the middle, regarding requirements and design models. This is a good place to spend time iterating, refining, improving your understanding, trying out different approaches, exploring alternatives. So I've been a big fan of both analysis and design modeling for a long time, using any of the available standard modeling notations. We have lots to choose from. In fact, here's a really important point to remember about modeling. Please do not invent your own notation. There are many established notations for various types of analysis and design models. We can go back decades to structured analysis with things like data flow diagrams and entity relationship diagrams. Those still work just fine. We've got the Unified Modeling Language, or UML, and its various models. We've got the RML, the Requirements Modeling Language. There are lots of kinds of pictures that you can draw to represent knowledge about the requirements or designs you have in mind for your system. And in fact, when I talk about writing requirements, what I really mean is representing requirements knowledge, and visual models are a good way to do that. So it's highly unlikely that you'll need to represent some information in a way that no existing picture can show, that requires you to invent some new model. The problem is that diagrams, like text, are a communication language. If you invent a new kind of diagram that other people don't know how to read, you can't communicate effectively with them. I had this happen once. I was reviewing some requirements documents for a client, something I've done a lot of, and they had drawn one standard kind of diagram, but the person who drew that had used, in addition to the standard arrow notations, two different arrows, dashed arrows or double-headed or something, that I didn't recognize. They weren't part of the standard convention for that sort of diagram, and I had no idea what they meant. There was no legend provided, so I had no clue how to interpret that diagram. So before you go making up your own diagrams and symbols, first make sure that none of the existing types of models will work for you, which means you have to become familiar with that set of models. And I'm pretty sure you'll find that there's something that will meet your needs in every case. Well, by creating models, these diagrams that represent various aspects of your proposed design, you can easily modify those as you get more information or new ideas that help you improve your initial design. So iteration is a key design success factor. All right, so moving on to some more design lessons here. We saw those. And I'm sure you've used products that were harder than necessary to use and led to unnecessary user errors. I encounter these all the time. So let's design products that are both easy to use correctly and hard to use incorrectly. I think this is really important. Last year, in addition to the Software Development Pearls book, I published another book called The Thoughtless Design of Everyday Things. You've probably noticed how many products we encounter in daily life. Could be computer products, could be things on your phone, could be physical things, cars, household items. And you look at them and you just wonder, what was the designer thinking? Did the designer ever use a product like this before in their own life? Probably not, or they wouldn't have designed this that way. I find that very irritating, so I wrote a book about bad design and the lessons that we can learn from it. I've got 70 design lessons in there, and one of them is exactly this lesson. Let's make products easy to use correctly and hard to use incorrectly. Another really important design point is that you can't optimize all desirable quality attributes simultaneously. Products of all kinds have many quality characteristics that describe not what the product does, but rather how well it does the things that it does. These kinds of non-functional requirements are a big contributor to customer satisfaction. If you're a designer, you need to know which attributes are most important to business success and focus on those, because there are trade-offs. Sometimes increasing one attribute decreases another. Here's an example. Suppose you want to get serious about security, and so you build into your next app multi-factor authentication. You know, if I'm trying to log into a website for a bank on my computer, then it might say, hey, wait a minute, we're going to send you a code by text message to your phone. You got to type in that code, and then you can log in. Well, that certainly increases security, but it greatly impedes usability, even down to needing multiple devices. So exploring these quality attributes during requirements discussions and aligning them with the project's business objectives helps the designers make appropriate trade-off decisions, because there often are compromises. So we'll drill down a little bit here into another design lesson, that an ounce of design is worth a pound of recoding. Rework, such as fixing designs that have problems, takes away time that you'd rather be spending building new software. And we're going to come back to this theme later. I hate rework. I hate doing over something I've already done. Now, a certain amount is unavoidable, but excessive rework is a problem. And one of the problems is that designs that are executed in haste can generate technical debt, shortcomings that someone must resolve in the future to maintain the product's proper functioning and expandability. Thinking about designs more carefully the first time can reduce technical debt, which otherwise needs to be repaid eventually. Rework to reduce technical debt often takes the form of refactoring. Refactoring is the process of restructuring existing code to improve its design, but without changing its functioning. You might decide to restructure some code to simplify it, make it more maintainable or extensible, improve its efficiency, remove duplicated and unneeded portions, or make other improvements. So refactoring is a way to pay off accrued technical debt a little at a time, but you're still doing something over. Restructuring a product's architecture to accommodate new functionality or to improve key quality attributes is especially disruptive and time-consuming. So, for example, if you didn't put enough thought into non-functional requirements like scalability or installability or something during requirements design and design explorations, and you have to go back and build that in later, that can be expensive and not very much fun. But as with most things in life, a thoughtful balance is most appropriate. One thing you learn as you get older is that either extreme position to one end or the other of the scale is almost always silly, and some sensible balance point in between is more reasonable. Time invested in considering the design, what my friend Ken Pugh whimsically calls prefactoring, is more than repaid by time you don't spend fixing problems later, at least up to a point. You can certainly waste time trying to perfect a design in the face of uncertainties, so you need to scale your design efforts to the nature of the problem. Nonetheless, creating better designs in the first place helps you avoid excessive redesign and recoding and rework. I don't like sentences about software that have a lot of words that start with RE in them, because that means you're doing something over. So moving on to the third topic in the book, which is project management. In my opinion, project management is not a discrete discipline. Instead, project management involves managing many activities that, in the aggregate, contribute to project success. Some of these activities include managing people, requirements, expectations, tasks. Commitment management's important. We'll see more about that later. Managing risks, communications, changes, resources, dependencies between tasks or individuals. You might be in a position where you have to manage contracts and suppliers. So all of these activities together constitute the domain of project management. These activities could be performed by a single individual or by a group or hierarchy of managers on a large project, or they could be done collaboratively by partitioning certain activities among multiple team members. So when I say project manager, I'm talking about whoever does these kinds of things on a project. So here are 4 of my 12 lessons about project management. Let's not give anybody estimates off the top of our head. The best answer to a request for an estimate is, let me get back to you on that. Off-the-cuff estimates that are prepared with too little information and too little analysis are often too low. And yet they sound a lot like a commitment to the person who's hearing that estimate. Projects, like icebergs, are almost always bigger at the end than you think they're going to be when you start out. You should incorporate contingency buffers to accommodate some expected growth. Let me tell you a little story about how that worked in practice once. One of my consulting clients was working on a very large project. They had several dozen people working on what they expected to be a 5-year project. Well, there's some data in the literature, mostly collected by a man named Capers-Jones, who's got a huge amount of data on software metrics, that suggests that on large long-term projects, the requirements continue to grow over the duration of the project, somewhere between 1% and 3% per month on average. Well, one day I was talking to a senior manager on this project at my client site. I told him this number and I said, well, let's consider that maybe your requirements could grow by about 2% per month. Does that seem possible to you? And he said, oh yeah, that could happen. All right, so an estimated 60-month project, let's say 2% growth in requirements per month. That means by the time you get to the end of that project, it might be more than twice as big as you think it's going to be today. He said, does it seem plausible? And he said, yeah, that could happen. So then I asked an important question. I said, do your project plans include any contingency buffers to try to accommodate some of that likely growth? And his answer was, altogether now, no. Well, I never found out exactly what happened with that project, which is one of the downsides of being a consultant. You often don't find out the bottom line. But I'm guessing it took more than 5 years to build, because things do get bigger. So let's plan for some of that in our schedules. Knowing that there's going to be growth, let's build in contingency buffers to try to soak up some of it. Excuse me. There's an old joke that software projects are always 90% done. You've probably encountered that scenario. There's a related joke, incidentally, that the first half of a software project consumes the first 90% of the resources. The second half of the project consumes the other 90% of the resources. These are only jokes because they are sadly close to reality. One reason why projects might seem like they're 90% done for a long time is that if you try to track the percent completion of individual tasks, you can think you're farther along than you really are. We don't do a very good job of estimating what percentage of a task is complete. So I prefer to do binary status tracking of small tasks. They're called inch pebbles. Get it? Inch pebbles, not milestones. And you track your progress by monitoring whether each of these small tasks are either done or not done. You get no partial credit. I think that's a more honest, realistic way to track our progress. You've probably heard of the iron triangle or triple constraint of project management, but I think that's an oversimplification. For one thing, it often doesn't, these diagrams often don't explicitly show quality, or if they do, you don't know if quality is an assumed constant or if it's just whatever it turns out to be. So there's a lot of problems, I think, with that iron triangle, although the idea is generally correct. But I think in terms of 5 dimensions that the project team has to have some flexibility around: scope, schedule, staff, budget, and quality. 5 dimensions. And the project manager needs to be able to adjust one or more of these dimensions to cope with changing situations. An over-constrained project will almost certainly fail. An added feature, a team member who departs, a risk that becomes a problem, an estimate that's too low, all of those situations will trash the schedule because the over-constrained project manager has no flexibility to respond to those events. I had a conversation once with a student in a class I was teaching on project management. I presented this idea and she said, well, all right, so our project has a feature set that, all has to be delivered. There can't be any bugs. We've got a fixed delivery date and that can't slip. I cannot get more people for the team and the budget is fixed. What should we do? Well, I said, I'm afraid you're probably not going to make it because any of these surprising things that come up are going to trash your schedule and you have no way to respond to that. So I think you need flexibility around one or more of these dimensions if you're going to try to realistically achieve success on your project. So I want to take a closer look at one of these project management lessons, which is that work plans must account for friction. I posted an article about this recently on my medium.com page. I heard a conversation at work one day. The manager said to one of my team members, Jamie, you're doing the usability assessments on our project right now. How much time do you spend on that? She said about 8 hours a week. And the manager said, okay, some other teams are interested in usability assessments. It sounds like you could work with 5 projects at a time then. Do you see any flaws in this thinking? 5 projects times 8 hours per week is 40, the nominal number of hours in a work week. So on the surface, this seems like a reasonable discussion. But the manager hadn't considered the many factors that reduce the time that individuals have available each day for project work. I call that project friction, and your work plans must account for this friction. I'm talking about project friction that slows things down here, not interpersonal friction. That is a real problem, but it's a whole different topic we're not going to get into. And the key point here is that people do not really multitask. They task switch. And task switching, at least doing that excessively, reduces your productivity because it takes time for you to gather together all the materials you need to work on a different activity, reload your brain with the pertinent information, and get rolling. You need to change your mental context to focus on the new problem and to remember where you were the last time you worked on it so you can pick up and move on to the next step. Now, when you're deeply immersed in some work, you're focused on the activity, you're free from distractions, you enter a highly productive mental state called flow. We've all been there. You know what it's like. It's when you're making great progress, having a good time, and all of a sudden realize that you forgot to eat lunch. Interruptions, like those that happen from frequent task switching, kill your flow, and it takes a while to get back to that highly productive state. So the key point to remember here is that the hours at work do not equal the hours that are devoted effectively to project work. Various studies, including my own experience with groups where we measured how we spent our time on projects every day for several years, we found that software people average only about 5 hours of effective, uninterrupted, attentive time for project tasks each day. That's not 8. There are also other sources of project friction that can reduce your productivity, such as having to get diverted to enhance or fix defects in an existing system or in previously completed work. Collaborating and communicating across distances, as we're all doing now, that slows things down. as do cultural differences among team members who have different communication and work styles. So you need to consider all of these factors when you're preparing estimates, making plans, and commitments. You can't simply assume that each team member is available for 40 hours per week of project work. If you do, that work you're anticipating simply won't get done. Every organization, every company, department, and team has its own culture. In brief, the culture describes how we do things around here. A healthy software culture is characterized by a set of common values and technical practices that drive the behaviors and decisions of people in the organization. A healthy software engineering culture includes commitments at the individual, project team, and organizational levels to build high-quality products through the sensible application of appropriate processes and practices. And if all goes well, the team members have a good time along the way, too. So here are several lessons I've learned about culture and teamwork, the fourth topic I address in this book. Knowledge is not zero sum. Let me give you a great example of that. I used to work with a guy I'll call Ron. Ron was very territorial about his knowledge, very protective. I would go ask Ron a question, and I could almost see the wheels grinding in his brain as we talked. He was thinking, wow, if I give Karl the whole answer to his question, he'll be as smart as me on that topic. I don't want that, so I'll give him half the answer and maybe he'll go away. So he'd give me half the answer, I'd go away, I'd come back looking for the rest, and he'd give me half of what was left. So I would asymptotically approach getting an answer. I found that very annoying. We were working together in the same department for the same company. And I think people should be a lot more open about sharing knowledge in that situation than Ron was. Unlike other commodities, if I give you some of my knowledge, I still have it myself. I can use it. I can give it to other people. If I'm a consultant, I can sell it maybe. A healthy organization fosters a culture of free knowledge exchange and continuous learning. I have little patience with people who hoard their knowledge rather than sharing it with their colleagues. Several of my consulting clients have told me, we're being asked to do more with less. I'm supposed to be more productive, but I can't get any more people. And so I would ask them the same question, which was, okay, what's being done to enable you to do more with less? And they always gave me the same answer, nothing. Well, if you're not given the means to make that happen, you should not expect higher productivity to happen by magic or by decree. You can't just replace your whole team with 90th percentile people. And remember, about half of all software people are below average in capability. Okay, that's just kind of the way it works. And those people all work somewhere. So if you want to make your team or yourself more productive, that requires a combination of better training, better processes and practices, and better tools. People talk a lot about their rights, but we should remember that the flip side of every right is a responsibility. This is true in daily life, it's true in our social structures, and it's true at work. Groups and individuals who collaborate have rights they can expect from each other, but they also have responsibilities to each other. I found that it's a good idea to discuss those and agree upon those rights and responsibilities early on, right up front, so we can facilitate effective and hopefully conflict-free collaboration. I think we all have the responsibility and the right to say to our colleagues with whom we're working, okay, this is what I need from you if we are going to jointly be successful. What do you need from me? Let's talk about that instead of making assumptions and just tacitly thinking everybody else is thinking the same way we do. You cannot change an organization's culture by issuing a decree, a policy, or a bunch of new technical procedures. Moving to new ways of working often requires as much cultural change as technical change, but it's harder and slower to make those cultural changes. Don't underestimate the challenge of changing the organization's culture as you start moving toward new ways of working. Well, here's another culture and teamwork example that I think is pretty important. No matter how much pressure others exert, you should never make a commitment that you know at the time you can't fulfill. And I had a vivid illustration of this once upon a time. I was leading process improvement activities in a large software division, about 450 software and systems engineers. One day I had a meeting with the division director, Martin, who was 3 levels above me on the organization chart. My boss was there as well. My boss was a good guy. But Martin was pressuring me to commit my group, my process improvement team, to achieving a specific improvement goal in what we considered to be an impossible time frame. I had explained to him what we were trying to do, what it was going to take, and he didn't like that. He was a pretty aggressive guy, Martin was, and he was sort of mentally competing with some other division directors in the same part of the company, and he wanted to get there first. So there was no way that his ambition could be achieved. But he was one of these guys who would say, don't tell me you can't do it. Tell me what I need to do to enable you to do it. And that sounds good in theory, but in practice, it simply wasn't going to make a difference. This was one of those culture change education things that was just going to take time. And this wasn't just our, conservative assessment. There was a lot of organizations throughout the world were doing the same kind of improvement activity. And we had read articles about this and talked to some of those people, and we knew what it typically took to accomplish this goal, and it wasn't anything like what Martin was demanding. So I finally told him, Martin, I can't commit to that. And he seemed pretty surprised, like nobody had ever said that to him before, and he didn't frankly know quite how to respond. Now, I was a little nervous, he was a pretty powerful guy in the organization. Well, what's he going to do? Hit me? Is he going to fire me? Is he going to yell at me? Well, I suppose he could have done those things, but he didn't. Instead, we negotiated. I simply was not going to make a commitment that I knew my team and I could not fulfill. And ultimately, he agreed with me. So commitments are important. A commitment is a promise that someone makes to perform an action or deliver some body of work in a certain quality state at a specific time. And here's the key. Commitments accumulate in dependency chains. Each commitment recipient depends on those who made the commitments to deliver. Here's an example. Maybe a project manager has made some commitments to a project sponsor to deliver some project at a certain time. And these are all two-way arrows. The project sponsor has agreed to provide certain resources to let the project manager get this done. Maybe the project sponsor has made commitments back and forth with the customer as well. A project manager might be working with multiple suppliers outside the team, and there are commitments back and forth there. And certainly we're getting commitments between the team members and the project manager and from one team member to another. So if everyone negotiates achievable commitments in good faith, they can rely on one another. But otherwise, this dependency chain is a house of cards. Any unfulfilled lower level commitments will undermine the chain and the whole thing collapses. Now, if you discover that you can't fulfill a commitment that you made as intended, for whatever reason, please tell those who are affected as soon as possible so they can adjust their plans accordingly. That's just being courteous. And I run into a weird phenomenon with every book I write. I've written a bunch of books. I always line up a lot of reviewers who are just a tremendously important part of the process. These manuscript reviewers, sometimes they're called beta readers, will give me feedback that I rely very heavily on to make thousands, literally, of changes based on their input to come up with a better book than I could write on my own. But an interesting thing happens. These are all volunteers. I invite a bunch of people to participate, and some say yes. And then after I start sending out chapters for them to review, I never hear back from some of them. There may be 3 or 4 or 5 people. It's like they were abducted by space aliens or took a vow of silence immediately after we started the review process, because I literally never hear from them again. I never get any feedback, but I also never get a message saying, sorry, I thought I could do this, but I'm afraid I can't. My apologies. That's all I ask. I think that's just a matter of being courteous. So I know what to expect. I know not to hound them and say, you got any feedback here? I know that maybe I need to line up some other reviewers or whatever. So my own personal practice is to undercommit and overdeliver. Maybe that makes me look overly cautious at times, but it also makes me reliable, and I'm okay with that trade-off. Quality is the fifth topic I address in software development pearls. People have tried to define quality for ages, but it's elusive. I've seen many attempts at it, but I'm aware of no all-inclusive, yet succinct definition that applies to software quality. So we can draw two conclusions from these many definitions I've found. First, quality has multiple aspects. And second, quality is situational. Each project team needs to explore what quality means to its customers, how to assess it, and how to achieve it, and then communicate that knowledge clearly to all project participants. Here are several lessons I've learned about software quality. You've probably heard the expression, you can pay me now or pay me later. Well, when it comes to software quality, you can pay now, or you can pay more, often a lot more, later. And the reason for this is that the cost of correcting a defect depends on when it was introduced into the product and when someone fixed it. Fixing it early costs less than fixing it late. Later on, it's harder to find the underlying defect that caused a problem, and usually more software components have to be modified. Requirements, designs, code, tests, documentation, and so on. So keep that in mind. This is a fundamental principle that should guide the choices we make about building versus patching in quality. Here's something I've never understood about our business. Organizations never seem to have time to build software right, and yet they always manage to find the resources to fix it later. This just baffles me. You'd think that if a system were so vital and urgent that management placed great pressure on the IT staff to rush it out, it would be worth building it properly. Too often, though, people cut quality corners in their haste. And somehow they always find the time, the money, and the people to fix it later on, even if you'd really rather be spending that time, money, and people building the next thing. My high school chemistry lab had a sign on the wall that asked, if you don't have time to do it right, when will you have time to do it over? I really internalized that message, and I always try hard to do the job right the first time. I think most people do try hard to do the job the first time, but it's up to management to make sure that we've got an organizational structure and a culture in which doing the job right the first time is enabled and expected, rather than figuring, well, we'll just throw something out there and fix it later. I've always found that it was better to ask one of my professional colleagues to help me find errors in my work instead of waiting for the customer to call and report a problem. Plus, have you ever noticed that when the customer calls to report a problem, they're generally not in a very good mood? I would prefer not to have those conversations. So I am a big fan of technical peer reviews. This is something I feel so strongly about that about 20 years ago, I wrote a book called Peer Reviews in Software, a Practical Guide, because that's something that I've been doing for many, many years and really appreciate the value of. In fact, I would never consider working in an organization in which reviews were not an intrinsic part of the culture. Now, in the rush to get some working software into the customer's hands, which of course we'd all like to do, people sometimes skimp on design and on sound software engineering practices. And that development project that we have to get out right away becomes tomorrow's maintenance nightmare. Accumulating technical debt in this way makes it harder and harder to change a product to add new capabilities. That accrued technical debt, like all debts, must be repaid later on in the production or maintenance parts of the product's life cycle. Taking on some conscious technical debt for good, sound business reasons is one thing. And that's, that can be valid, provided people understand that there's a price you pay, like with number 43 there, later down the road. But unconscious technical debt that arises from rushed development, that's a bigger problem and a little less easy to justify. Let's drill down into this very important principle that high quality naturally leads to higher productivity. Organizations and individuals who develop software would all love to be more productive. And quality problems pose one of the greatest barriers to high productivity. When you're aiming for a goal or trying to solve a problem, it's always good to start by understanding why you are not already achieving that goal. So if you want higher productivity, ask yourselves, why isn't your productivity as high as you'd like? And in many cases, you might discover that rework is a big contributing factor. Teams plan to get a certain amount of work done in a specified time, but then they have to fix problems found in completed work, or maybe divert effort to repair a system that's in production. That rework saps time and it lowers morale. One way to boost productivity is to create high-quality software from the outset so that teams can spend less time on rework, both during development and following deployment. Did I mention that I hate rework, doing things over that I've already completed? I truly do. Now, some rework is unavoidable. It's the nature of our business. We have uncertainties, we have changes, and so we have to expect to do some of it, but we shouldn't just accept ongoing infinite rework as a routine part of our business. We can avoid some of it. Not very many organizations measure how much time they spend on rework, but those that do can get scary numbers. I've seen literature reports that some departments, some organizations spend 40 to 50% of their total software effort on rework. So just imagine how your team's lives could be better and how their productivity could be increased if you could say, cut that in half. So you might think about measuring your own organization's rework level. How many times do you have to do things to get them right? How many times do changes pass through the change process before they're implemented correctly? How many times do you have to do regression tests because the first time we tried to do the test, we had things that were wrong, we had to go fix them and then test it all again. So you might think about measuring that. There are 4 components to the cost of quality, and this kind of gets back to the idea that there are 2 major classes of software rework: fixing defects and paying off technical debt. As I mentioned earlier, these defect correction costs grow over time. So finding and fixing defects early, or even better, preventing defects, is cheaper than waiting for the customer to report a problem and then dealing with it. The total cost of quality consists of the time and money you spend on 4 activities: preventing defects, detecting them through quality appraisal activities such as reviews and testing and static code analysis, fixing defects found prior to release, that's called internal failure, and external failure describes fixing defects that are found after release, after you thought you were done. So if you can invest in defect prevention to have fewer problems through better processes and earlier detection, then that helps you spend less time on later stage rework, which leaves you more time for new development work, thereby increasing your productivity, and everybody wins. All right, the final topic area that I address in this book is process improvement. I've been involved in software process improvement since the early 1990s, about 1990 in fact. And so this is an area I've got a lot of interest in. I have never known anyone who could truthfully say, I am building software today as well as software could ever be built. And unless you can legitimately make this claim, you should always look for better ways to conduct your software projects. And that's what software process improvement, or SPI, is all about. The objective of SPI is to reduce the cost of developing and maintaining software. It's not to generate a shelf full of processes and procedures. It's not to comply with the dictates of the process improvement or project management framework that's currently the most fashionable. SPI is a means to an end, the end being superior business results, however you define that. Here are several lessons I've learned from leading process improvements over the past 30 years. Watch out for management by business week. Sometimes people leap to adopt the latest new development approach, hoping that it will magically solve all their problems. But before you settle on any new approach, let's go back to that important question. Ask yourself, what's preventing us from achieving those better results already? Do some root cause analysis to understand the problem before you choose a solution that may or may not actually help. I'm a big believer in root cause analysis. If you haven't done that, it's surprising how easy it is and how efficient it is at focusing a group of people's attention toward understanding the real reasons why they're experiencing certain problems or not achieving a particular goal, so that you can develop actionable solutions to address those fundamental issues. When people are asked to do something different or extra, which often happens when you're undertaking some process improvement work or transitioning to Agile or whatever, your instinctive reaction is to wonder, well, what's in it for me? That's a very logical, natural human question. But a better question is to ask, what's in it for us collectively? Effective change initiatives must consider the team's collective results, not just the impact on each individual's productivity or effectiveness or comfort level. And I recently encountered a good story about this situation. I have a friend who's a vice president at a bank. Of course, banks have lots and lots of vice presidents, and she's kind of a low-level one. But her job is managing the software team that maintains and updates and operates the software by which this bank processes over 1 billion credit card transactions a year. Serious stuff, high transaction throughput. Well, a couple, 3 years ago, the bank's managers decided everybody was going Agile. All of their mini software developers and projects were now going to be done Agile. So they took all the developer people, put them through a mass training on an enterprise level Agile approach. And that's how projects are all supposed to be done from now on. Well, they never explained why. They never explained what problems are we having or what are we not accomplishing for which Agile is the solution. That gets back to management by business week, perhaps. Instead, they were just told this is what we're going to do now. And my friend there said, not only did the people ask, they didn't ask what's in it for us. They basically said, why are you making me do this? And they never got an answer. Well, that's pretty discouraging. And in fact, it was totally inappropriate for certain projects. Remember, my friend was managing a department that processed 1 billion credit card transactions a year. That is not an environment in which you want to move fast and break things. That is not an exploratory environment with a lot of uncertainty. Totally different kind of world for which Agile may not be a good solution. But that's what they were told. And so you naturally aren't real appreciative and receptive to that from the start. I think the best motivation for changing how people work is pain. Pain is a powerful motivator. I don't mean artificial, externally induced pain, like managers or customers who demand the impossible, but rather the very real pain we experience from our current ways of working. Sometimes, though, the project pain isn't apparent to everyone involved, so they might not be motivated to make useful changes. For example, if the development team is taking some approach that causes problems and higher maintenance requirements downstream, but there's no feedback loop so that the development team learn about those problems, they don't have any reason to change what they're doing. They don't realize there's a problem. So I think it's important to have change leaders explain why doing something different can reduce the pain that some, but maybe not everybody's even aware of. Change leaders need to keep the effort visible, treating the process like a project and gently but steering continuously both team members and their own managers in the desired new direction. So I love this phrase, gentle pressure, relentlessly applied. And many, many years ago, my father told me once, look, if you're ever in a crowd, a bunch of people that are trying to get through the same doorway, just keep your feet moving and you'll get there. And he was right. I've tried that. It actually works. Just keep shuffling your feet and you'll move. And this is true for process improvement as well. If we just keep a little gentle pressure steering both our team members, our colleagues, and our managers toward the direction we're trying to go, you'll get there a little bit at a time. That's a lot better than trying to make radical changes all at once, because people can only do so much change at a time. All right, one more example about process improvement that I think is worth remembering. Unless you take the time to learn and improve, don't expect the next project to go any better than the last one. Process improvements and other changes don't happen by themselves for no reason. Something has to trigger them, providing the information and the impetus to try something different to get better results. So your teams have to take some time to assess their previous performance and results so they can focus some effort on the right improvement targets. The process of reflecting on an experience to learn how to handle the next one better is called a retrospective. I'm sure you're familiar with these. All software project teams, I think, should perform retrospectives at the end of a development cycle, such as a release or an iteration, at a project's conclusion, and when some surprising or disruptive event occurs. Now, a retrospective is not just a free-form gripe session. It's a structured sequence of activities that you go through of planning, kicking off the event, gathering information, prioritizing issues and analyzing them, and then deciding what you're going to do with the information collected. The inputs to a retrospective include input from the team members regarding not just their project experiences, but also their emotions. That's an important part of a retrospective, is to get the human factor here so we know how people felt about what was happening. You might have some objective data from project records of timelines and events that happened and any metrics that were collected. And the retrospective can produce a number of outputs. If you've come up with particularly useful insights, put those in a lessons learned collection. And if you happen to have such a collection, take the time at the beginning of a project to study it and learn from it so you don't have to repeat the learning of those same painful lessons. Things that happened that surprised you, that were unexpected, might be risks for the next projects to consider. And also, you might come up with some ideas for changing your processes that will give you better results going forward, and that feeds into an improvement action plan. The most important output from a retrospective is the team's commitment to making changes that will improve their work life and their effectiveness. A retrospective on its own won't change how things go the next time. It has to feed into these ongoing SPI activities. So if you're holding retrospectives, but then nobody ever does anything with the results, don't waste your time with the retrospective. Just keep doing on whatever you do and hoping it works. If you do these, remember that a retrospective is more of an interpersonal interaction than a technical activity. And as such, it must be conducted with consideration and respect for all of the participants. So we've covered a lot of ground quickly here, make you aware of some of the kinds of things I've learned in my career that I thought were important. But it's also important to remember that you cannot change everything at once. That's the final lesson in the book. No matter how many points of pain, improvement ideas, or desirable destinations you identify, people and organizations can absorb change at only a limited rate. I once knew a highly motivated 20-person project team that tackled 7 major improvement activities simultaneously. The priorities weren't clear and the resources were spread thin. So despite their enthusiasm, this team accomplished little on their change journey. An important keyword in any change initiative is focus. You need to identify a small number of feasible and high impact areas to address initially and see them through to completion. So effective change at the individual, team, or organizational level requires that you honestly assess your current performance, identify problem areas, and then select changes that you think would add value and prioritize them. And one way I did this when I was the developer is that whenever I started a new project, I would always pick out 1 or 2 areas that I wanted to get better at. They might be estimation or modeling or algorithm design, unit testing, or anything else. Then I would take the time to learn about those topics and look for opportunities to apply them on my current project. And once I got through some learning curve and had those as part of my routine practice, they were in my toolkit so I could do a better job on every project going forward. Process improvement is a cycle, and here's a change cycle I found to be effective. As I mentioned, you need to begin with some kind of assessment, which could be very informal, or have some outside consultants come in and do an organizational assessment. The first steps in each chapter of Software Development Pearls is really helping guide you through the thought process of assessing your current performance. And based on what you learn, you might plan what you're going to do differently in terms of learning or acquiring tools or training or practicing new techniques or whatever. And then comes the hard part. You actually have to put those plans into action. Too many of these kinds of improvement efforts end up in an infinite loop between assess, plan, and you never actually do anything different. But if you do, then you have to give those new ways of working time to begin to pay off so you can verify that they're giving you the results that you want. And then you can go back, do an updated assessment, and move on to the next improvement area. There's always something we can do better the next time. Well, I hope you've gotten some ideas from this presentation about practices that would be valuable for your personal performance and your project teams. Software Development Pearls presents 60 lessons and many technical practices that apply to a wide range of software project activities: requirements, design, project management, culture and teamwork, quality, and process improvement. And like most practitioners, probably all of us, I learned many of these lessons the hard way by making mistakes and then thinking about what I would do differently the next time. As a consultant, sometimes I was fortunate to learn about other people's mistakes, as well as seeing what they did well that succeeded, so I could learn some of these lessons quicker and with less pain than suffering through them all myself. So I wrote this book to collect many of these important things that I've learned since I started programming decades ago, with the hope that they'll save you some time and accelerate your path through the many learning curves you face as a software development professional. I also hope you'll share your own lessons learned about software development with your colleagues and be receptive to their experiences so we can all learn how to build better software. So thank you for sticking with us here, and I think we have time for some questions if Susan's heard any input from people.
We do have one question that came in. Similar to the project triad, pick 2. Is it the same for your 5 dimensions, so you can get 4 perfect but not all 5?
That would be kind of the extreme case, yeah. It's not quite as simple as pick 2. And what I think of is in terms of understanding how much flexibility does the project team have in each of those 5 dimensions of scope, quality, schedule, staff, and budget. Some of those are going to be fixed. They're going to be constraints. Some of them are going to be what I call project drivers. They're key success drivers in which you have a little bit of flexibility. You have no flexibility around a true constraint. You have a little flexibility around a driver. And then you have other, hopefully, dimensions that I call degrees of freedom, where the project manager has more latitude to adjust those so that you can achieve the project's success drivers within the limits imposed by the constraints. So I actually describe what I call a flexibility diagram in the book, which kind of lets you graphically see where's my flexibility here. And it lets you draw an irregularly shaped pentagon in a radar chart or Kvyat diagram, if you prefer. And the key point here is the smaller that pentagon is, the more constrained it is. And key message, all 5 dimensions cannot be constraints or you're going to have a problem. So it's a little more complicated than just saying pick 2, but it's the same idea.
Karl, we thank you so much for presenting. Always a pleasure.
My pleasure. Thanks very much, Susan. Thanks for joining us, everybody, and we'll see you the next time.